Common mistake. I have 6 CDs. What are those? Okay, well, let's go with books. On a shelf. I have 6 books on a shelf. And people say, oh, well, then the order doesn't matter. If the question is about 6 books on a shelf, the only thing that would matter is what order are they in, and then rearranging them. Would you please figure out, with your calculator's help, because this is a big number, if I have 6 books on a shelf, how many different ways could I arrange them? And I hope you know, if you're going to use your calculator, what factorial means and what permutation versus combination means. Because some of you might think it's a C, and some of you might think it's a B problem. All right, so I'm going to pause for a second while you answer that question. 6 books on a shelf. How many different rearrangements are there? I'm going to pause while you try that. Okay. Let's say these are the 6 books. I'm making them different colors, of course, so that I can tell them apart. There's my 6 books on the shelf. Now, let me change the question. What was the probability that I was going to put them in that order? Wait a minute. You have a big number on your paper, right? What was that? That was all the possible ways I could have done it. What I want is that order. How many of that order is there? Only 1. So it's 1 out of whatever you just figured out. Now, I hope you used a P, because this is a permutation question. A combination would mean you don't care what order they're in, and then what's the point of the question if you don't care what order they're in? Okay, so the point of the question is rearranging it as many times as you can. So bottom line, you should have done 6 factorial. Oh, by the way, it would look like this. 6p6. 6 factorial over 6 minus 6 factorial, which is 0 factorial, which is defined as 1. So it's really just 6 factorial. If you wanted to use the calculator's button, you'd say, let's 6 NPR6. And then it would put them in the right spots, and you would get a big number. What did you get? 720. So then what was the probability I was going to put those up in that order? If I was going to grab the 6 colors I have, well, 1 out of 720 chance that you would have guessed what order I would have put those in. Okay. What if it was this order, or, notice the word or, there, I've just rearranged them to that order. Then it was the other one, or this one, and that means, or means what again? Add. 1 plus 1 is 2 out of 720. All right. Now, I want you to take your best guess at this one. Let's say there's 52 cards in a deck of cards, and I pull one out. What's the probability you're going to guess the right one? Don't say it. Figure it out. Use the calculator. I want a decimal answer. I pull out one card. What's the probability? You'll guess it right. All right, write down your guess on what the card would be. Take your guess. Write down your guess, not blurt it out. Okay. Do you get, there's only one of your card? I don't even care what your guess is. It doesn't matter. There's only one of your card. And then there's 52 cards possible. You should have said 1 out of 52. Why isn't it some huge number? Because I didn't ask you like what order the deck is in. That would be a huge number. Okay, so here's the card. The Ace of Spades. So I had it, I pulled it ahead of time, and he totally just guessed it. So he got 1. Anybody else guess it? All right. Now, I actually, on purpose, ahead of time, before he said it though, chose the ace of spades because I knew that it would be more popular than average guess. Okay, how many of you picked an ace? Raise your hand if you did. All right, and I wonder if there's a correlation between, put your hand up if you are typically a card player. Okay, so the card players on average picked aces. Okay, aces are a really good card. If you play cards, you want an ace. They're good. They're powerful. They like win in the card games. Okay, so it's kind of like this. Think of a flower name. Write it down. Go. Don't say it. Write it. Don't say it. Write it. How many of you picked rose? All right. Now, was it a true probability, though, that was random? No, because I picked the most common. Pick a number between 1 and 10. Write it down. Ready? 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 Write it down. Quick. All right. How many picked 7?
Whoa, what?
Look at that.
Whoa.
Okay. So, you picked 3 in a row, right? All right. It's because you're picking very common answers. And I'm choosing those on purpose. So that increases the probability you'd be right. There's a lot of flowers in the world. How many picked daffodil? See? All right. None. African violet, anyone? No? Okay. There's a lot. What? No. All right. So right now, would you please change your mindset from probability back to just how many are there? All right. How many of you, if we go with, this is always a judgment call on hair. People are like, I don't know if my hair is brown or blonde. Okay, but you're going to have to make a decision right now. How many of you would consider yourself a blonde person? Raise your hand if you are. You may identify as blonde if you wish. 1, 2, 3, 4. Only 4? Okay, fine. 5. Oh, and another one over here. 6. All right. 6 blonde people. And then I'm going to just use the category of not blonde. And that's going to be everybody else. So I'm just going to count everybody. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 28 kids in here today. So then if there's 28 kids total, then I know that this must be 22. This is blonde. This is not. Then, let's say I'm going to have a committee of 4 people. And I want to have 1 represent the blondes and 3 not blonde. Because I want to have proportionate representation of the blonde community. Then how many different groups could I pick? Whoa. That is a tricky question, but it's not that hard. I'll give you this hint. It has something like 22C4 in it. And I'm not saying that's the right answer. I don't need you to multiply this all out right now. I just needed to set it up. I'll say it one more time. I want to choose a committee of 4 people. But if I just said committee of 4, I hope you would have gotten that it was 28 kids choosing out 4. That's too easy. We've already done that. What I'm asking is, I want to have 1 blonde and 3 not blonde people. How many different ways could I do that? All right. So then try to stay organized. Would you agree there were 6 blonde people? How many am I choosing out? And then, notice I said and. I also need, and is different than or, right? And I also need, out of the not blonde people, to pick how many? 3, and means times. Or would have meant add. I don't want this or that. I want this and that. And that's how many different combos there are. This one I can do in my head. If I have 6 things and I choose them out one at a time, how many ways are there to do that? 6. 6 times 22C3. I can't do 22C3 in my head, but I hope you would remember that that was 22 factorial over 22 minus 3, which is 19 factorial, and an extra 3 factorial. If I write it out, I can do it probably faster than your calculator. 22 times 21 times 20 over 3 times 2. Then I can do some canceling. The 21 is 3 times 7. Cancel, cancel. And the 20 is 2 times 10. Cancel, cancel. 22 times 10 is 220 times 7. Okay, I'm not that fast, but it's not too bad. You think that's wrong? Okay, I must have went too fast. 22 times 21 times 20 is the correct answer on the top. And then I factored 21 into 7 times 3. So it's 22 times 7 times 10. 22 times 10 is 220. 220 times 7, that should be it. Oh, I multiplied my 22 times 7 wrong? Dang. 7 times 0 is 0. 7 times 2 is 14. 7 times 7 is, or 7 times 2 is 14 plus another one. Oh, dang. The old carry the one got me. Okay. Now you've got a couple examples. You should be able to do this now. So here's my question. Do you guys know that every state has 2 senators? No matter how many people are in that state, they get 2 senators. Minnesota doesn't have that many people. We got 5 million here. I mean, it's not tiny, but tiny would be like South Dakota. They have less than 1 million. But they still get 2 senators. And the people in California sometimes get grouchy about this because they have 10 times as many people as we do in Minnesota, but yet they only get 2 senators. 10 times as many people, still only 2 senators. What makes up for that? House of Representatives, because then you get proportional representation, and so if you get more people, you can get another senator or whatever. So we have, I think it's 8 in Minnesota. Can anybody verify it's 8? All right, thank you. So let's say we were going to have a committee where we got one of the Minnesota senators and one of the reps, one of each, to come and like talk at our school. This little committee of 2 people. How many different combos could we pick? Remember, we have 2 senators, and we want one of them. We have 8 reps, and we want one of them. Did you have 2 choose 1? Raise your hand if you had 2C1. Awesome. And did I say or? No, I did not. I said and. So that's times 8C1. That's how many different little 2-person committees we could have. All right. Now let's say, can you name one of our senators from Minnesota? Okay, Klobuchar. So, can you name one of the reps from Minnesota? Dean Phillips. All right. Then my question is, what was the probability? Now, granted, some people have better name recognition than others, so therefore it's kind of like that flower question where I said pick a flower. More people are going to pick rose because it's the most commonly picked thing. Some of these people have better name recognition than others, but what was the probability I'd pick that? Well, how many were there? What was this? 60 what? I heard 5 and I heard 16, I heard 66. What? 16? Okay, so there are 16 possible combos, and that one is one of the 16. Does that make sense to you? It's one combo. I know it's two people, but it's one combination. Okay. Then, see if you can extend this to a little trickier. Ready? You're playing a card game, and there's 52 cards in the deck. I'm going to deal out 2 of them. Every kid in here gets 2 cards. Okay? I know you're thinking, is there enough cards? There actually is. We could do that. But I'm not going to take time to do it. But it's about 25 of you times 2 would be 50. Oh, we have extra people today. Okay, fine. Maybe we don't have quite enough in the deck. But imagine for a moment I had enough cards to give everybody 2. All right, so now here's my question. How many different combinations are there? There's a lot, right? Well, you don't have to like look them all up. Just write down what C what or what P what. Now, does it matter if I handed you 2 cards and you never like kept track of which one was which? You just kind of like picked them up and look at them. Do you get the order does not matter? It doesn't matter if I give it to you like the first card or the second card. I know you could keep track of that if you wanted to. But just so you know, when you play most card games and you pick up your cards all together, it doesn't matter whether they give you this one first or that one next. It didn't matter. They're all shuffled kind of together. So all of our problems are going to do C's for cards. Okay, C for card. Get it? And I know we could make the order matter. There are certain games where it could make a difference. But if you're going to pick up all the cards at once anyway, then it's like the order didn't matter. So it's a C question. And how many of you figured out it was 52C2? Raise your hand if you had that one right. Awesome. Then that's your what's possible. There's a lot of possible hands. Now, here's the trickier part. What's the probability that you look at yours and it's ace, ace? Now, it seems really complicated, but it's not. Let me show you. Would you agree that this is what's possible, and therefore I'm putting it on the bottom? This is what I want is going to go on the top. Are you with me so far? Anytime it's probability, you turn it into a divide question, and what you want goes on the top. Well, what I want is there are 4, pay attention, 4 aces, and I'm choosing to get 2 of them. But wait, there's more. There's also 48 other cards, and I'm choosing to get 0 of those. Does this make sense to you? I want you to think about it. This was aces. This is not. There's 48 cards that are not aces. Now, if we do card questions and you are not the type of person who plays cards, I totally understand. You might not know what the heck a heart is versus a diamond, or how many kings are there in the deck. So if there's any card questions on the test, you will be allowed to ask me questions like, well, how many cards are there in the deck? Or how many aces are there in the deck? How many jacks are in the deck? I'll answer all of those questions for you. So if you're not sure, if you don't understand cards that well, I can help you with that. Do you remember balancing equations in chemistry? Watch me balance this equation. Look at that. 52, 52. Look at this. 2 plus 0 makes 2. See how those balance nice? And I have found this, that if kids understand that whole balancing thing, they always get this question right. So try to understand the balancing thing. Because, when you look back at your answer, it's really quick to see, do the 2 left numbers add up to the bottom left number? And do the red triangles there, do they add up to the one on the bottom? See if you can do that same thing, except now it's going to be a 5-card game. I'm going to pass 5 cards to every player. They pick up their 5 cards, not 2, but 5 cards. And what's the probability that one of them, exactly one, not at least one, that's actually a pain in the butt question. If they say at least one, then I have to do, they could get 1 or 2 or 3 or 4 or, that's it, I guess. You can't have 5 aces. That's a cheating deck. Okay, anyway, but I think you get the idea. I just want exactly one ace. And hint, that means I want 4 not aces. See if you can set this up just like I did last time. It's going to be, I call these CC over C questions. CC over C. Oh, it's not that bad. 52, and then I'm going to have, what are all the possible things? I'm going to be dealt how many cards? 5. And then I have aces and not. It's not that bad. KT, do you get this? Okay, then tell me how many aces there are. And tell me how many not aces there are. No, not things in the deck that are not aces. All the things that are in the deck. Okay, so then, is your equation balancing so far? I bet you can finish it. Bet you can. Remember the question again was I wanted to get exactly one ace and all the other cards are different. All right. And 48C. There you go. You get how that balancing thing really makes it pretty easy to do? Okay. One more. You ready for this? Do you know have anybody heard of Texas Hold'em? All right. Oh, gosh. So in Texas Hold'em, you're dealt 2 cards, so we're back to that. What's the probability you will be dealt what's called Big Slick? In case you don't know what that is. Anybody know what that is? It's an ace and a king. An ace and a king. No, there's no jack involved. It's an ace and a king. So anyway, blackjack is a completely different game. This is, I'll say it one more time, 2 cards were dealt. So that's what's possible. That goes on the bottom. What I want to have is 1 ace. And by the way, there's 4 aces in the deck. And I want 1. And there are 4 kings in the deck. And I want 1 of those. Compare with the kid next to you. See if you get the same thing as them. I think you did it right from what you were just saying a second ago. Can you tell me what you did on top? See, a lot of people stop right there, but I love what she did because, see, it doesn't balance right now. So would you tell me that last piece that you said? Guys, you're talking too much over there. I can live with a little bit, but that's just a little too much. Okay, good, keep going. 44C0. Now, do you have to have that? Here's why you don't have to have that, because when you choose 0 of something, it's like it never happened. You know what I mean? But if you want it to balance, like I said before, now it balances. And this will continue to balance because I picked 0 of them. See what I mean? I like that way that you did it. But those of you that didn't have this part, you didn't have to have that part. It would just equal 1. If you typed it in a calculator, it would equal 1. So timesing by 1 doesn't do anything, right? Okay. There. Now you guess what? We're actually ready for 2 days of homework. I'm not going to give you twice as much homework. I'm trying to say I have now taught you today's and tomorrow's. So if it felt like a little bit harder than normal, that's probably because it was. All right. So, no, I'm not giving you 2 days of homework. I'm saying you are now trained on 2 lessons at once. So tomorrow will be easy. All right, so today, let's go look at the homework together. I'm going to pause for a second while you find the one posted for today. Okay. At Giordano's, Mrs. Price, by the way, she's a math teacher that left about 9 years ago. Kind of weird, but echoes of the past here. Mrs. Price, favorite pizza place. Pizzas can be topped with 9 different veggies, but wait. 9 different choices, but I'm only going to pick 5 veggies. Do you get why I just did 9C5? There were 9 choices, and I chose 5. Times 6 different meats to choose from. 6 choose, well, how many meats do we get to have? 3. And 1 cheese times 1 cheese. Well, how many cheeses were there? 2. There were 2 different cheeses. 2 choose 1. But wait, what about pineapple? First of all, how many of you like the pineapple Hawaiian pizza? Raise your hand if you're a Hawaiian person. It's usually about half the class, and that's a little less than average in here. All right. I know some people think it's an abomination. Fruit on pizza? What is wrong with this? Why do you think I put 1C0 on here? Yes?
Because there is just the choice of pineapple.
Yep. Exactly. That's the pineapple thing. Now, if you didn't have that, would it be wrong? No, because what do you think this equals? 1, and it wouldn't change your answer. But it's just showing I chose 0 of those. Okay, let's move on to number 2. The number of ways in which a committee of 5 people can be chosen from a group of 8. Don't overthink this. This isn't like the blonde versus not blonde question where I have subgroups. This is just 8 people and you're picking 5. And here's your big mistake you could make. Why would that be wrong? Because then order would what? Matter. And I don't need order to patter. I want it to be a C question. So I should say 8C5. Remember, always the bigger number goes on the left. That's how many you have to choose from. And this is how many you actually chose. Okay. I'm going to go on to the ones and just tell you which ones you can skip. I looked through them and figured out which ones would be the most logical ones to skip. Skip this one, B, selecting 2 of 8 employees. You definitely should do C. I'm going to talk you through C in a moment because a lot of kids get confused by that one where you're rearranging letters. And I get people are thinking like, only if counts if it makes a word. This is not a word find. It's just rearranging the letters math, M-A-T-H. And so that's kind of like books on a shelf. You know what I mean? So I'm just rearranging the M and the A and the T and the H. How many different ways can I do it? Well, does the order matter? The whole point is M-A-T-H is one order. A-T-H-M would be a different order. The order definitely matters on C. Okay, anyway. Then move down to problem 4, and we're going to skip C as in cat and D as in dogfish. There is a dogfish. All right. So, is a permutation or a combination, if they're keeping track of first, second, and third place, can you tell if that's a P or a C? P, because the order matters. And then you got to actually do it. Well, that means they picked out, don't get fooled by seeing third place and thinking there's 3 spots. They have winner and, so there's 4 spots actually. They're keeping track of 4 spots. So if it's a P question, then I got to put the bigger number on the left. There were 10 people to choose from. Anyway, I think you can do that. Don't forget, this is a P. The order does matter when you're rearranging letters. That's the whole point, is what order are they in. Don't try to guess what the words are. You know, you don't have to make special words. A-T-H-M is just fine, even though it's not a word. And that's 5 things, yes. No, math is 4 letters. And then since the order matters, it's a P, and then you have to figure out the rest. Okay. It was a fairly easy day today, but I taught you that other stuff with the card questions and that. That's going to make tomorrow go really easy. That's all I got for you for today. And